that we're looking at is to do with acids. And one of the things that you need to really be very confident about is what it is about an acid that makes it behave like an acid. So one of the things I'm hoping you're going to spot is from the formula. I've written the formula of 3 really common acids underneath here, and I wonder if you can see what they all have in common. There's something that they all share. I'm hoping that you've noticed that they all have hydrogen in their formula. Okay, now that's part of the definition of an acid. It has to be able to have hydrogen in its formula, but that's not all. There's something else that these acids need to be able to do with that hydrogen. Now, to concentrate on that and to understand what's going on with it, I'm going to have a look at HCl. And I need us to think back to our work on bonding that we did right at the beginning of the year. Now, HCl is capable of bonding in one of 2 ways. This type of bonding has a shared pair of electrons between the hydrogen and the chlorine. This type of bonding is a transfer of electrons from the hydrogen to the chlorine. 2 different kinds of bonding. This one is covalent and this one is ionic. Now, HCl, hydrogen chloride gas, has this kind of bonding. Hydrochloric acid has this kind of bonding. And the difference between the 2 is hydrogen chloride gas has to be dissolved in water in order to become hydrochloric acid. So there's something very special about dissolving in water that allows it to change its bonding from this type to this type. Okay? And what I want to do is have a look at some weird property of water that might help us to understand that. So to do that, I have a fun little experiment here. I've got some water in my burette and I have a little plastic rod here which I'm going to charge up on my cardigan for want of something better. And I want you to see what happens as I hold my charged rod near a stream of water. I'm going to open the tap here and let the water run out. Okay, is that showing? As I bring the charged rod near it, look what happens to the water. Water likes charged things. It likes them so much that even if the substance isn't charged, it can encourage it to become charged. Let's have a look at these diagrams again. So here, this is an HCl molecule with no charged particles. This one has changed its bonding to ionic. So we have an H plus ion and a Cl minus ion. And the thing that makes an acid is this ability to release H plus ions. And they can only do it when they're in water. So we're going to have a look at another experiment in a minute to help prove that this is the case. I've got some hydrogen chloride dissolved in water, hydrochloric acid, and here I've got hydrogen chloride dissolved in something called toluene. Now, toluene is what we call an organic solvent. It doesn't have to be toluene, there's lots of other things I could have used, but this is effectively not water. It looks a bit like it, but it's not water. It smells quite like petrol, it's quite unpleasant. So what I'm going to do is to demonstrate that this one is genuinely acidic, the one that's dissolved in water, and the other one that's dissolved in toluene is not acidic. Okay, so there is my hydrochloric acid, my conventional hydrochloric acid. I'm going to put some indicator paper into it, and I hope my indicator paper will go red, proving that this is an acid. And there we are, definitely gone red. With the other one, the hydrogen chloride dissolved in toluene, I'm going to do the same thing. Add a little bit to the beaker. Oh, it smells terrible. And test that with some indicator paper. I dip this one in. You can see it has not gone red. So this one so far is not acidic. But now I'm going to do something really crafty. I'm going to add some water to this mixture so that the hydrogen chloride that's dissolved in the toluene has the opportunity to dissolve in some water as well. So I've got some water here in this bottle. I squirt a little bit in. My hydrogen chloride now has the possibility of dissolving in water rather than the toluene. And if I take my same piece of indicator paper and dip it in now, you can see that where it got into the water, it is now acidic. So that's the crux of this whole issue, that it's not enough to have the chemical, it's not enough to have the HCl or the HNO3 or the H2SO4. They must be dissolved in water, and the process of dissolving in water allows them to release H+ ions. That's what makes something acidic.